Daniel Collin, forecasting solar wind speeds from solar EUV images, please.
Yeah, hello. I'm Daniel. I recently started my PhD at the German Research Center for Geosciences in Potsdam and at the Technical University of Berlin. And my project is about forecasting of the solar wind speed at the L1 point. And I want to use solar EUV images from the SDO AIA for that. And the good thing about these images is that we can clearly identify one of the main sources of the solar wind, which is coronal holes. And we can see them really nicely as these dark, big structures in the solar images in certain wavelengths. And, well, we've already heard this a lot, that solar wind, well, can damage satellites, can be bad for astronauts. And therefore, we want to predict the solar wind speed to be able to predict solar storms. And my goal is to build a prediction model based on the solar images by analyzing coronal holes and extracting characteristics of coronal holes. Oh, I need this pointer. Oh, okay, here we go. And yeah, so my first approach in building a prediction model consists in, as I just said, analyzing coronal holes in the solar images. So I start by taking a time series of images. In my case, I took data from 2010 to 2019, and then for each point of time, I filter out the coronal holes of the solar images. I take 193 angstrom and 211 angstrom, because there you can really nicely see the coronal holes. And then I'm using some segmentation algorithm developed in my working group in Potsdam to filter out the contours of the coronal holes, as you can see them here. And then I want to measure the area of the coronal holes, and I also want to get information about the location of coronal holes on the solar surface. So I divide the solar surface into different sectors of different longitudes and latitudes. Here you can see these 9 sectors. And then out of each sector, I measure the area. So for each point in time, I kind of get a 9-dimensional vector. And for my whole series of images, I end up with a multivariate time series, and from this I will extract another set of input features that I will then put into a prediction algorithm. But I'm also using a second source of information, which is the historic solar wind speed, because coronal holes are very long-lasting structures, and many of them persist on the solar surface for several solar rotations. So a solar rotation is 27 days. So if we look into the past 27 days, we are really likely to see the same coronal hole and see the effects that this coronal hole already had on our solar wind speed as measured at the L1 point. So looking at the historic solar wind speed, we can also infer a lot of information. And then my idea was to not only look at one point in time, but to take into account different points in time of my time series to also capture the development of my features and yeah, get like the dynamic behavior. So from both of my time series, I extract the value at different points in time. Here I've chosen just to show you better 4 days. And then I get a set of input features that I then put into a prediction algorithm. This can be any sort of regression algorithm. And I try to predict the solar wind speed 4 days in advance. I have tested this for several prediction algorithms. Started with very simple things like doing just a linear regression with my input features, doing polynomial regression, but also more complex things like neural networks and LSTMs. And surprisingly, the method that performed the best for me was a very simple polynomial regression of order 2, together with some L1 regularization. And here we can see the results for a time frame of a couple of months. And we see that the black line is the actual observed solar wind speed, and the red line is my prediction. And we can see that I am able to really nicely capture the variations in the solar wind speed. Also, the blue is my my training data, and the orange part is my test data. So I did a cross-validation split here. And I'm also performing really well on the test data. Yeah, and at the end, I want to emphasize a little bit what are the key features, or maybe what's new about this method, is that here I have very simple features. So I just measure the coronal hole area and have some information about where the coronal holes are on the solar surface. And a rather simple method with the polynomial regression, so it's very nicely physically explainable, and you can retrace the contributions of each features, and it still outperforms many other solar wind speed prediction models that are much more complex. And there is a couple of models, for example, that take the solar image and then do convolutional neural network or vision transformers, and with this very simple model, I'm outperforming many of these models. And I also found out that taking into account the feature history really improves my prediction, and not only looking into one point in time. And yeah, so as a conclusion, I think this can be a very nice baseline model for my future research, and I definitely want to extend that because, well, with this I cannot capture CME effects, for example, so that's something I want to change in future. And I'm also thinking about doing some like more proper machine learning by also taking into account the whole solar image and to capture more information. But yeah, so far this simple model works really nice. Thank you.
Questions, please? We have one question and second question.
You mentioned a couple of other algorithms for finding coronal holes. Have you come across Chimera at all?
I don't think so. What is that?
It's another coronal hole algorithm detector thing, but there's a couple of papers by Ty Garten that are probably very similar to what you do. That's just if you haven't come across them, I thought I'd let you know.
Yeah, cool. Maybe you can tell me afterwards and
Cool,
give me the
yeah.
reference. Would be nice. Thanks.
Yeah, we have one more question.
Very cool. Simple is better always. I'm wondering, since you do the segmentation and find where the coronal holes are, if this could be, this is just real-time thinking, if this could be applied in some way or combined with other algorithms, for example, Mohammed's work on SEP forecasting. If you take the information about coronal holes, I don't know, have you thought about any extensions to this?
Yes. So one logical step would also to be to include, for example, active regions, do segmentation of active regions or other sources of solar wind, and then also try to include these features into the prediction model. Yeah, so there's lots of things I'm considering. Just have to decide for something.
So, and in terms of interpretability, can you say something physical about the changes in the speed, meaning that slow solar wind might come from the boundaries of coronal holes versus the insides of the coronal holes where it be faster and so on?
So I've looked a little bit into like which areas of the sun contribute the most to the solar wind speed. So not very surprisingly, the strongest impact is done by like this equatorial region in the middle. Especially if I want to predict like 4 days into the future, there's also some like this left equatorial part is also important, and like a little bit the upper and lower one. But it's, for example, this one is not really important, or this one. Apart from that, I've not looked that much into the physical explainability so far, but I'm also planning to do that more in the future.
Thank you.
Thank you. We had one more question, no? No. We have one question online, actually. Daniela Lagadas, please.
Hey, great presentation. I have a slightly related question to one of the first question that you got. Have you considered that using a different algorithm will give you a different area for the coronal hole, and that may impact your prediction? So you may get different areas or more fragmented or less fragmented coronal holes. Would that impact your prediction?
Yes, I did not try different segmentation algorithms, but I know that this is a factor that at the moment, since I do this like in between step or pre-processing step by extracting the area with a certain type of algorithm, I can introduce a bias into my prediction model. That's why I also plan to do the prediction directly on the solar image to like skip this step of using another segmentation algorithm. So with that, I could avoid that, hopefully.
Okay.
But thank you.
Good luck.
Thanks.
Thank you. So if no questions, let's move on to the next speaker.